This video will be about the two last classes of organic compounds that you need to know, and also it has a bunch of practice questions closer to the end, so please stick around. As always, I want to remind you that you have wonderful magical table R, which has functional groups of all organic compounds that we've studied and general formula of all compounds that we studied and the example of the naming. So it is a great resource to check all your answers during the test. But now let's continue with amines. Amines are organic compounds formed when one or more hydrogens atoms in the ammonia molecules are replaced by an alkyl group. So over here is the molecule of ammonia, but if one of its hydrogens get knocked off its place and will be replaced by alkyl group, let's say methyl group, it will no longer be ammonia, it will be an amine. To be specific, it's methylamine. Ammonia is not an organic compound. By itself, NH3 is a gas at room temperature and inorganic compound. It doesn't have a single molecule of single atom of carbon, so it's not organic compound. But when methyl group or any other alkyl group replaces one or more of its hydrogens, it becomes an organic compound. If ammonia that has one methyl group hanging off it is called methylamine, then you probably can guess then if there are two methyl groups that replace hydrogen, that would be dimethylamine. And to nobody's surprise, three methyl groups that are attached to the nitrogen would be called trimethylamine. When alkyl groups that replaced hydrogen in ammonia get longer, then we would have to identify the location of the functional group. So here it is sitting on the first carbon in this chain. So this compound will be called 1-propanamine. And over here, the functional group is sitting on the second carbon. So this one would be a 2-propanamine. Amides also have nitrogen in their formula, just like our amines do, but they also have this oxygen connected by the double bond to a carbon over here. So they are relatively easy to distinguish. So here it is. Let's count all the carbons. 1, 2, 3. So propanamide. Please notice only one letter difference, amine versus amide. And this is already means different structure and means different properties. Okay, so as it was promised, here are some practice questions. A chemical name of this compound is, well, we see this compound, and I hope you immediately see this functional group that tells you that it's an amine. We check how many carbons this amine has, 5 penta. So the answer here would be 1 pentamine. Okay, let's see. Amines, amides, and amino acids are categories of isomers, isotopes, organic compounds. Sounds like a ticket. Okay, which formula represents alkyne? Well, alkyne, triple bonded hydrocarbon, has general formula of CnH2n-2. Once again, reminder, you have all these general formulas in your reference table. Use it. Once again, question, what is the chemical name for this compound? Once again, let's look at the compound. Let's find a functional group of this compound. Here it is. Another amine. Let's check how many carbons is here for bute. 1 butamine, definitely. Okay, what do we have here? What is the name of the compound with this formula? Okay, once again, let's look for the functional group, and easy to spot right here, another amine. Oh, definitely dangerous on amines this day. So 3 carbons in the chain, and on the first carbon we see NH2. So it's 1 propanamine, definitely. Which compound is the isomer of C2H5O, C2H5? Well, let's kind of turn it into molecular formula. C4H10O. Let's see, where do we see this combination? 4 carbons. We see it in 3 and 4. And then we can see that this is exactly the same molecular formula would be here. Because we can see 4 carbons, 9 plus 1, 10 hydrogens, and oxygen, just like this compound over here. So what's next? Ethanoic acid reacts with 1-butanol, an alcohol. Can react to produce water and compound classified as, well, we already know that acid and alcohol produce ester and water. This question over here, while relatively frequently found in the tests, is not exactly a question. It's a gift of free point because you are given a functional group. You have to find it in table R and look up what class of organic compounds it belongs to, and very easily to identify that aldehydes are the answer. Let's see, identify the element in diethyl ether that allows it to be classified as an organic compound. The answer is straightforward: carbon. The moment we see carbon, we should be thinking it might be an organic compound. Not all compounds that contain carbon are organic, but there is not a single organic compound without carbon in it. Now, state the number of electrons shared between the carbon atoms in one molecule of organic reactant. So, since we're talking about reactants, we should be looking at the left part of this equation. Water is inorganic compound, so we should be looking at these ethene molecules. And if we are considering this molecule over here, between carbons we see 2 lines. It means that there are 4 electrons shared between them, because each line means 2 electrons. And the last one, state why the reaction is classified as synthesis reaction. Okay, so we can see that on the left we have 3 reactants, relatively simple, and on the right we have only 1 product. That's enough to classify it as a synthesis. Simpler, smaller compounds are synthesizing something bigger and more complex. That's synthesis. Explain in terms of the strengths of intermolecular forces why the boiling point of diethyl ether at standard pressure is lower than the boiling point of water at standard pressure. Well, we know that boiling point depends on vapor pressure produced by the substance. So if the substance is having strong intermolecular forces, has a strong force of attraction between molecules, that particular substance does not create a lot of vapor pressure and its boiling point is pretty high. So since the boiling point of diethyl ether is lower than water, we can assume that intermolecular forces, the forces of attraction between molecules of diethyl ether to each other, are relatively weak, and it easily overcomes those attractive forces and goes flying as a gas, creating vapor pressure and boiling at low temperatures. Here is an example how you can answer that question on a test. Diethyl ether has weaker intermolecular forces than water and because of that boils at a lower temperature compared to water. Don't forget, if you ask to explain something in terms of a particular thing, for example, in terms of intermolecular forces, you have to mention them in your answer. You have to refer to them as a point that explains behavior of matter. Let's see. Draw structural formula of an isomer, same structure, different structure, same molecular formula, of the product that has the same functional group. So we have to draw an ether. So oxygen, and we can put carbon here and give it a longer alkyl group on the other end. That probably will do the trick. We still have the same number of carbons. We still have the same number of hydrogens. Oxygen in a new place, new location, new structure. And this is an isomer. This is methyl propyl ether. Write the name of the class of organic compounds to which compound A belongs. So I start to look for functional group, and I found one right here. Looks like it's an alcohol. Identify the element in the compound B that makes it an organic compound. Of course, that would be carbon. Now, explain in terms of elements why compound B is not a hydrocarbon. Well, because it contains oxygen. Hydrocarbons only supposed to contain hydrogen and carbon. That's why they call hydrocarbons. Which compounds are isomers of each other? Well, you can draw all of the compounds and compare who has the same number of the same atoms but different structure, but I kind of can see how these two compounds can be very easily isomers of each other. They have the same number of hydrogens, but different location of the hydroxyl group. And this question down here, a reaction between an alcohol and organic acid, classified as esterification reaction. Explain in terms of chemical bonds why the hydrocarbon in equation 1 is unsaturated. Well, since we're asked to explain in terms of chemical bonds, we have to mention it in our answer. Ethene is alkene. It has a double bond in its structure. Identify the class of organic compounds to which the product of equation 1 belongs. Well, we see there carbon, hydrogen, and chlorine, so it's clear how light. Let's go to question 85. State the number of electrons shared between carbon atoms in the molecule of vinyl chloride. Well, here is our molecule of vinyl chloride, and between two carbons we see two lines, the double bond. Each line represents 2 electrons, so total number of 4 electrons shared between the carbons. Okay, so the question 84. Draw a structural formula of the product of equation 1. Well, we're very helpfully provided with the name. So 1,2-dichloroethane. Eth, 2 carbons. Ane, only single bonds. On the first and second carbon, there are 2 chlorines, chlorine and chlorine, and the rest of the bonds will be occupied by the hydrogens. Here it is. And now last 3 questions. Okay, so State the number of electrons shared between the sulfur atoms in the dimethyl disulfide. Well, these are the electrons shared between two sulfurs. It's a one line, so 2 electrons. Identify the polarity of hydrogen-iodine bond and the polarity of sulfur-sulfur bond. Well, hydrogen-iodine would be a polar bond because hydrogen has relatively low electronegativity and iodine has high electronegativity. Sulfur, 2 atoms of sulfur, they are twins. They have equal electronegativity, so nobody really wins this tug of war of electrons, so that bond would be non-polar. Okay. Explain in terms of electron configuration why sulfur atoms and oxygen atoms form compounds with similar molecular structures. Well, here are the magical words. In terms of electron configuration, we need to mention that oxygen and sulfur are elements from group 16. So they have the same number of valence electrons. That's enough of an answer.